Hello everyone, Assalamu alaikum. Welcome to my YouTube channel. Today I will be discussing about a very cool example of deep learning. So in this video, I will introduce you to a deep learning project on pneumonia detection with Python programming language. Now, pneumonia is an inflammatory condition of the lung, mainly affecting the small air sacs called alveoli. It is an infectious and fatal respiratory disease caused by bacteria, fungi, or a virus that infects human lung air sacs with a load full of fluid or pus. Chest x rays are the common method used to diagnose pneumonia, and it takes a medical expert to assess the results of an x ray. In this project, I will take you through this whole process of creating this model for this pneumonia detection using this language and of course using a library, and let's get on with it. So we will be actually implementing this in Python using two online platforms. You can definitely do it on your local machine, but today I'll be using two online platforms. So if you're not already familiar with these two platforms, don't worry about it. I'll be teaching you how to use them in a quick and easy way. So the application that I'll be implementing is based on X-ray images of patients that are either suffering from pneumonia or are healthy. So I'll be using Kaggle database, that is an online platform that to store your databases. So there are a variety of databases that you can access from Kaggle, and I'll be implementing this project using Google Colab. So you can of course use your local machine for running this application as well, but it will require some space and some patience, obviously, because if you don't have GPUs specifically, then it will take a lot of time to train the models that we are going to use today. So let's first talk about Google Colab. So you need to log on to this website, colab.google, and it will take you to this interface. And as you can see, you have option of creating a new notebook directly, or you can use this option as well. So let me open this one, and after it loads, it will automatically ask you if you want to use or create a new notebook. You have some options of examples as well to get you started. So what I'm going to do is quickly jump to this new notebook for creating my project. Of course, this all takes some time, so you have to be patient as well. So what I'm going to do first is give my project a name because it is based on pneumonia. So I will uh, name this randomly like this, or you can name whatever. Now let's talk about this interface for a bit. As you can see, there are multiple options, and this interface might be familiar for you, especially if you have already used Jupyter Notebook. It is quite similar to that one, but there are certain differences as well. So what I need to do is I need to choose some options. Let's see. I have this code option. What I can do with it is I can create a new line here like this and this and so on. Okay, so similarly, if I want a text line or a heading, what I need to do is click on this one, and it will add a cell, a text cell, which is not a coding cell, but it is kind of a heading. So you can do that as well. So let's delete these extra lines. And then I have a very cool option, especially if you don't have a GPU at your end. What Google Colab provides is a free GPU to use, but it has its limitations as well. It is quite good, but not as powerful as you would think, but it works very well for the application that I'm going to do today. So how can you access this GPU? It's quite simple, straightforward. What you need to do is click on this option and change runtime type. So as you can see, it has an option of a GPU and a TPU. So I'll be using a GPU because if I use CPU for my application, it will take quite a long time because I'll be using a model of CNN, which is quite complicated. So and also it will be a work on images. So the application itself is quite complicated to handle on its own using a CPU. So I need more computing power. So for that, I'll be using a GPU. But be aware that if you want to use a GPU, select it from the beginning of your coding, because if you select this part from in the middle of the or in the middle of your coding, then what it will you will have to do is you will have to manually run all the commands that you have run before. So anyway, um, let's save it and try to connect it. So yeah, once connected, you will see this green dot, and you will see this notification as well, connected to Python 3. Now this setup is done. Let's head on to the Kaggle database that I was talking about. So I'll be using this chest x-ray images for pneumonia. um, Kaggle is a big platform that contains a lot of databases, different types of databases that you might need for your models to train and test for preparing your applications. You can you can choose any model that you want that is contained with this Kaggle. Now, what I want to do is I have already selected the model, so I will go around and see what I have in this model. As you can see, there are some examples of chest x-rays, just like I want. And in the database, there are three different folders for it: a test folder, a train folder, and a validation folder. And in inside each folder, there are two subfolders: normal and pneumonia. So so they have separated normal patients from pneumonia patients already. I'll have to use them accordingly. What you have here is you have two options. You can either download this whole database, which is around 2 GB, and then upload it on Google Colab. You can either do that, or what you can do is you can directly link this to your Google Colab, which is what I'm going to do. So working like this is quite simple and easy. It doesn't require your hard disk space. It doesn't occupy your hard disk space, and it requires no calculations from your CPU whatsoever, because you are using an online platform. So of course you can do it on your local machine. Process is similar. You just have to skip out some commands that I'll be using in this Google Colab. So we have seen the database, we have selected the database. Now we know what folders are in the database. What we need simply from this database is its API command. This command I'll be copying later. So let me get back to the Google Colab that I created, and I have a GPU enabled as just a reminder. So what I want to do now is I'll start with importing some libraries that I'll be using. I'll be using FastAI library for implementing this project. So let's start with importing those libraries. After importing my libraries, which I have just imported, what I need is my database. Now, there are certain things that you need to do for a database. As I told you, you have two options: either download database directly from Kaggle and upload it on Google Colab, or uh, or you have a workaround. You don't even need your disk space to be occupied. What you need is an API that connects your Google Colab directly to your Kaggle. Now I'll show you how to do that right now. What you need to do is import OS, and after that you need to import the environment, set the environment for this kaggle database that you want to use. You just need to type in these commands and it will be ready. Now comes the part where I need to decide which is the directory. So for checking out what my directory is, all you need to do is click on this folder on the left hand side, and what you need is you need to find out what the path is. So you need to copy this path and paste it here. If you want to place your database or your required data in this folder, then it's fine. Otherwise, I don't want it in my sample data, so I'll skip this part. So I just need this, and after you execute this, you have this folder, not this sample data folder. You have this space, and whatever database that you want to get will be copied here. Now let's get our database which we have just connected. Now let's get onto Kaggle and connect our database. Now what you need to do is get to your database and click on these three dots or options and copy API command. That's all you need to do. It's that simple. So we have copied that API. We have copied that API code. What I'll do is run this command. So in order to run this command, I'll copy this and I'll include an exclamation mark so that it knows this, so that Python knows that it is a runtime command. And now it is downloading the required data to your folder, to your required folder, which is this one. As you can see, the folder is appeared in a matter of seconds, but you have to wait till it is completed, the upload is complete. It will only take some seconds. Now our download is complete, but as you can see, it is in a zip format, and the library that I'm using is FastAI, and the model in this FastAI doesn't pick up data, or the data loader or the data loader that is provided in this FastAI library doesn't actually work with the zip file, so I have to actually unzip it. So for unzipping, it is quite simple. You just write exclamation mark unzip, and then what you need to do is provide the link of the zip file, which I'll copy it from this part and then place it here, and then space, then -t, and then space, and where I want to put it is here in this folder, the same folder. So I can just copy this same path. Actually, I'll just copy it here and exclude this zip part. So it will create this same name folder here in the same directory and unzip the files for me. It will take some time, and let's see. So you can see that this folder is being unzipped, and in that folder you have another folder which is chest x-ray, chest underscore x-ray, and it will have test and train and validation folders and all the images. So once that is completed, let me get back when all of this is completed. Now that all that unzipping is done, you can check that. So it has three folders, three subfolders: test, train, and val, and each folder has two subfolders as well. So now I'm familiar with that. Now I have my database ready and to be used. What I need to do is set a path variable from where I get my test data. So for that, what I need is this, the link to this path. So I will just copy the path and paste it here. That's it. So this is my path folder. Now in order to train my model or create my model, what I need is to load all these train images in the database so that I can learn which type of X-ray is of normal patients and which type is of pneumonia patients. So for that I need a data loader, and in this fast AI library you have this image data loader that is quite neat. Let's try to use that. So I'll have my data as image data loader. Because I'm loading it from my folder, so I will select from folder. You have quite a lot of options here. You can work around with this. Let's try to figure out what I need. So firstly I need to set the path where my folder is. So I've already set the path here. Then I will check indicate that images are in the main directory. How to do that is simply putting this dot here. Then the next thing I need to do is I want to use 20% of my data for validation. So simply I will do valid valid state equals 0.2. That's it. And then I want to seed it. I'm just seeding it to ensure that same split happens every time. Then I need to resize all the images to the same format. So item, sorry, so this to resize, this thing is to resize this to this format. Okay, so that's it. That's my image data loader, and I'll run this, and yes, it works. Now we need to ensure that whether the data that we got from Kaggle is actually those extra images. So what I need to do is simply use this data.show command. It will load some of my images. I can set it to maximum number. So as you can see, I have this. So as you can see, I have verified that the same database that I was using from Kaggle is here as well. Now that this is clear, let's try to do some learning. So because we need our model for learning the parameters of these images in order to predict whether if you have a new X-ray image, whether it is of a pneumonia patient or of a healthy patient. So for that we need to make our own model. Or you can use a predefined model. I'll be using a predefined model, or you can make your own model. So what you need to do is you need to make a learn variable that will contain the model that you are using, that you are trying to use for your images. So in this library, FastAI library, I have this vision learner function that I'll be using, and I'll provide the data to it. Okay, then I need the model. So the model that I will be using is ResNet 50. Now, the thing about this is it has a variety of models that you can use. There is this ResNet family, EfficientNet family, MobileNet family, VGG family, DenseNet, SqueezeNet, LXNet, Vision Transformer, etc. There are a variety of options. You can choose whichever model you think fits your required application. I'll be using this ResNet 50. You can use your own. Then I'll be providing the metrics that I'll be using. So I'll be using the accuracy metrics because that's all I need to know if whether my model is accurate or not. And then model directory is my path, obviously. Let's try to run this. Now what it will do is download that path or uh, and try to load this model. Now the model is loaded. Now comes the hard part, or the waiting part, you can say, because we have selected our model. Now we need to implement that model to learn the parameters from these images. For that, what we will do is on this learn on this model that we created, what we need to do is we need to pass a function that we need to find an appropriate learning rate. So what it will do is find an appropriate learning rate and plot out a nice curve for us, through which we can decide which learning rate best describes our application at hand. So let's just run this and sit back and relax for some time, because it will definitely take some time. Alright, now the learning part is completed. It took almost 2 minutes for it to learn the parameters, and as you can see, it created a nice graph for us. So all we need to do is select the appropriate learning rates. So all of you who are familiar with deep learning models, or who are familiar with neural networks training, you should know that what learning rate is and how important it is to select a good learning rate. Because if we don't select an appropriate learning rate for our model, what it will do is it will keep on oscillating, or it will eventually die out, and it will not converge. And by converging, I mean it will not be an accurate model. So you can see this valley point here. So this is a very cool way to understand when your model actually starts to learn. So according to this learning rate find method, what it does is plot the point where it thinks that after this point, the model actually tries to or starts to learn. So what we need is we need to find a learning rate in between this point and the point of divergence again, where this loss, as you can see, this loss again starts to go up. So the learning rate, a good learning rate, should be between these 2 points. So I can see 2 points here as 10 to power minus 3 and 10 to power minus 1. So our appropriate learning rate should be in between them. So what I will do is from this learning rate, I will try to fit my model to the given parameters. So let's try fitting the model to our parameters. Now what I need to do is, once I have this curve or this learning rate set, what I need is to fit my model according to my given parameters. That is quite easy. Let's try to do that. Now, this method of this library, what it does is it fits our model according to the model that we chose, which was ResNet 50. It will fit our model according to these images and this learning rates. So, but what we have to provide is number of epochs that we want, because our model is big enough, it is complex enough. So what we can do is we can keep these epochs to a minimum. So in between 4 to 10 will be appropriate. I'm choosing 4 because of the time limitations. You can play around with this and choose an appropriate number of epochs for your own. This is a hyperparameter as well. The next thing is, because I want an appropriate learning rate between 10 to power minus 3 and 10 to power minus 1, so I will start on with this learning rate 1 and end it with learning rate 2. So this is what I'm going to do. Now this one is actually very heavy, so it will take some time, quite a lot of time actually, to run to its epochs, because this is the actual training of our model and fitting of the weights and parameters according to those that best suit our model. So once it gets completed, I'll get back to you and show you the results. Okay, so as you can see, it took a lot of time for this to run. So it took almost 16 minutes for this to complete on a GPU. Imagine how long it would take for a CPU to run this. And also note that this was not a very high-end GPU. It was a normal GPU, but still it took 16 minutes. For a CPU, it would have taken quite a lot of time. Anyway, so let's check our results. So for each epoch, you can see the training and validation loss is going down, way down, and our accuracy is increasing. I'm pretty sure if I did it for uh, 3 or 4 epochs, I would have achieved a better accuracy than this. Anyway, but this is what we got: 97% accuracy on our uh, set on our images based on ResNet 50 model. Now what I'm going to do is I'm going to interpret the results using a confusion matrix. I'm going to see how my results look like. Let's do that. Using our learn model that contains our ResNet model, based on all these things, it will be useful for me to plot the results or visualize the results, what I get. So let's do that. I'm gonna run it. Now it is just preparing the results for me, and after that what I need to do is plot the results in the form of a confusion matrix. So I will just type in plot. Let's just wait for the results, and then I'll implement this one and we'll see the results visually. Now that this is done, let's visualize these. Now as you can see, I got a confusion matrix that uh, that predicts the results for my dataset. So these are the actual results. Okay, so out of 629 times, uh, 607 times the model predicted that the patient is normal, and out of 1700 times, I guess, 1666 times the model predicted that the image is of pneumonia patients. So it is really good result, as you can see. So now what we have visualized this, you can actually improve this by increasing the number of epochs, or you can change the learning rate. You can play around with this and get your required results, whatever you want. You can get more accurate results, but just don't try to overfit your model. Now what I need to do is test this whole um, model that I created or defined. So for testing, what I need is an test image. So as you can see in my test database, I have two directories of normal and pneumonia. So I will test a normal patient's data and a pneumonia patient's data and try to figure out whether my learned model, or my model that I have prepared using that learning rate and using that ResNet 50 model, actually predicts whether it is a normal patient's X-ray or it's a pneumonia patient's X-ray. So let's see. For that I need an image. So I will define an image. Pill image is taken from the same library that I'm using, which is FastAI library. Now, using this pill image, I need to create an image, and in that create image, I need to provide the path. For finding the path, what I need is, because I'm testing on this test data set, so I need path of a normal patient's image. So what I will do is copy this path and place it here simply. So place this whole image and then I'll run it, and this image is created now. Let me test if this image is actually that image. So just let me see. Yes, it is indeed an image. This of healthy patient. Let's see if the model that I created or model that I trained is actually predicts this as a healthy patient's image. For that, what we need is the learn model that I created dot, and on it I will run predict, and this prediction will be done on that image that I provided, and I need to print out the results. So I will put this whole thing in the image. So let's see. Yes, it actually works. So as you can see, it was a normal patient's X-ray and it predicted normal. So let's test another one. Let's test a pneumonia patient, and let's do this one. I copied this path and I have to copy this command. Okay, and I have to actually copy that again because I copied that. So yeah, this one. Then again, let's see the image. This is what a pneumonia patient's X-ray looks like, and let's predict the results again. So it is actually pneumonia. So there you go. This was the complete application that I tried to compile for you. So hopefully this was helpful, and this whole application makes sense and this whole coding makes sense. You can do the same thing on your local machine But if you are running it on a CPU, just remember that it will take a whole lot of time and memory from your CPU. So this was it. If you have any questions, drop them in the comment box below, and I'll see you in another video.